Black holes are terrifyingly dense space objects, pulling inside everything that comes too close. Nothing can escape their clutches, even a beam of light. At the same time, black holes are some of the most mysterious objects in the universe. According to their mass, black holes are usually divided into three categories. Stellar black holes have a mass from a few to hundreds of times the mass of the Sun. Intermediate black holes should range from 100 to hundreds of thousands of times the Sun's mass. Scientists are now actively hunting these missing link black mysteries. But the real behemoths of the cosmos are supermassive black holes. They have hundreds of thousands to billions of times the mass of our Sun. Most supermassive black holes lie in the centers of their home galaxies. You can probably say that they sit in the gravitational driving seat. Meanwhile, hundreds of billions of stars, planets, and moons orbit them. Let's have a look at the biggest black holes astronomers have found so far. NGC 6166 is a monster that has grown to have a mass of 30 billion solar masses. It's actually an elliptical galaxy that has an active nucleus in the center. It's also one of the most luminous sources of X-rays. The galaxy's supermassive black hole powers two symmetric radio jets in the opposite direction, which is the result of the infall of gas into its center. Another peculiar thing about NGC 6166 is that it shows a blue shift, which means it's moving toward us. The next supermassive black hole is located in the constellation of Draco, approximately 10.4 gigalight years from us. The mass of this supergiant is more than 30 billion solar masses. Besides being incredibly massive, the black hole is also really big. If it replaced our Sun, the diameter of this hole would extend to the orbit of Pluto. This S5 Thera 1481 is one of the most interesting black holes on our list. It has a mass of 40 billion solar masses and is actually a blazar, the most energetic of all quasars, which are super bright distant objects. The blazar's luminosity is 300 trillion times that of the Sun and more than 25,000 times as great as the luminosity of all 100 to 400 billion stars of the Milky Way galaxy combined. But since the distance to this quasar is about 12.1 billion light-years, we can't see it directly. But we know that the central black hole of the quasar consumes huge amounts of matter, about 4,000 solar masses of material every year. IC 1101 is a supergiant elliptical galaxy. It's the most massive known galaxy so far. Since this galaxy is elliptical, it isn't filled with gas. That's why the star formation in that region is very low. As for the black hole at the center of IC 1101, it has a mass of 40 to 100 billion solar masses and emits clear radio signals. Recently, astronomers have discovered a gravitational space wonder that is swollen to really unimaginable proportions. The black hole I'm talking about is TON 618, and it's a mind-boggling 66 billion solar masses. The thing is so massive that astronomers had to think of a new term to describe it. They came up with an ultramassive black hole. Imagine gathering all the stars in our home Milky Way galaxy and squishing the matter they're made of into one black hole, and it still won't be enough to create a TON 618. If this monster of a black hole replaced the Sun, its radius would be more than 40 times the size of Neptune's orbit. You probably know that black holes are made of matter packed together as densely as possible. And still, it doesn't mean that black holes are some kind of space predator, roaming galaxies and munching on everything they come across. TON 618 still has a whole galaxy filled with stars and other stuff happily orbiting it without getting pulled inside. What I want to say is that the perception of black holes as giant vacuum cleaners is wrong. In reality, it's incredibly hard to grow a black hole. Try to do it and you'll see.
A black hole is an eerie place where those laws of physics we studied at school stop working. If a massive star runs out of its fuel, it sometimes becomes super dense and buckles under its own weight, collapsing inward and bringing space-time along. As a result, the gravitational field of this new object gets so strong that nothing can escape it, not even light. That's how a black hole is born. The black holes closest to our planet are called Gaia BH1 and Gaia BH2. They were discovered thanks to the data collected by the European Space Agency's Gaia spacecraft, hence their names. Both are about 9 to 10 times more massive than our Sun and are located a mere 1,560 and 3,800 light-years away, respectively. In cosmic terms, they're situated in Earth's backyard. And there's something seriously wrong about these black holes. So, should you pack your emergency bag? Let's find out. The remarkably close black holes are likely to represent a previously unknown category of these mysterious objects. What sets them apart from others is that they're orbited by stars at much greater distances than scientists have observed previously in other black hole companion star pairings. Normal black hole companion star systems are known as X-ray binaries. They are usually bright in radio and high-energy X-ray emissions. They swallow matter and emit powerful bursts of energy, which makes them pretty easy to spot. Now, why did it take astronomers so long to spot these massive black holes residing right inside our home Milky Way galaxy? All because they're almost invisible. In the past, astronomers spotted black holes by looking for the remnants of their meals. The thing is that when a star or even a cloud of interstellar gas is pulled into a black hole, it leaves behind a trail of electromagnetic radiation. And scientists use it to detect the presence of a black hole. But unlike other holes discovered before, Gaia BH1 and BH2 are pitch black. They don't seem to be snacking on anything at the moment. This makes them inactive, or dormant. So astronomers had to use another method. They tracked the movement of two companion stars orbiting these cosmic monsters. The stars, similar to our Sun, wobbled a bit while traveling through space. To researchers, it was a sign that something with a lot of gravity, like another star, was tugging on them. Interestingly, when they examined the area with the help of telescopes, they didn't find anything emitting radiation. So the whole situation only made sense if there was a black hole involved in the process. Luckily, Gaia is perfect for spotting invisible black holes. Thanks to its state-of-the-art equipment, it can accurately measure the motion and position of billions of stars. No other instrument is capable of such precision. Gaia's observations were backed up by the data received later by other observatories. For instance, NASA's Chandra X-ray Observatory, as well as the South African Meerkat radio telescope, revealed no visible light coming from Gaia BH2. So even though they detected nothing, it was still valuable information. It told astronomers a lot about the environment around the black hole. A lot of particles are coming towards it from the companion star in the form of stellar wind. But the researchers didn't spot any radio light. It means that the black hole doesn't have much of an appetite, and not many particles cross its event horizon, or the point of no return. Unfortunately, it's still unclear why that is. Anyway, should we be worried about those mysterious black holes lurking in the darkness of space so close to our planet? I've got some good news. There's absolutely no reason to worry. First of all, these black holes are sleeping at the moment. And it doesn't look like they're going to wake up anytime soon. Secondly, they're still too far away to affect our life. And it's not like black holes know how to travel.
Emergency lights are going off, sirens blaring. The spaceship is shaking like crazy. The cosmic darkness beyond the portholes is illuminated by pulsating flashes. The astronauts are strapping themselves in and looking at the screens, cold sweat breaking on their foreheads. Straight ahead, space is cut in half by a blinding beam. Nothing in the universe can stop it. It looks like a humongous airplane jet stream, millions of times more powerful than any jet could make. There's no way to go around it. The leader of the space expedition orders everyone to turn around immediately. That was a black hole jet, a real monster of space. The holes, like huge vacuum cleaners, swallow everything that falls beyond their event horizon, the boundary between space-time and the place where it disappears. If you find yourself close to this border, you're doomed. Even light can't escape the gravity of a black hole, and it's the fastest thing in the universe. The holes not only absorb matter, but also shoot jets into space, mysterious beams thousands of light years long. There are no black monsters near the Earth, but let's imagine if one suddenly popped up close to the Sun. The hole immediately starts devouring the star. Strong gravity pulls one side of the Sun more than the other. The hole tears the Sun into ribbons, eating it just as you would eat spaghetti off your plate. Physicists call this phenomenon spaghettification. When the monster's finished its meal, it hiccups, and, like laser swords, two jets cut our galaxy in half. Astronomers are observing a similar catastrophe right now, billions of light years away from us. A black hole from the 3C321 system is bombarding a nearby galaxy with a jet of X-rays, gamma rays, and electrons accelerated to the speed of light. The onslaught has been going on for 1 million years, and we're lucky it's taking place at a safe distance. If a jet comes close to a planet similar to Earth, it'll vaporize the atmosphere and the ozone layer. All life on the surface will disappear. Only deep underground dwellers will survive. If a black hole does appear next to the Sun, though, we won't live long enough to see the jet. The monster will absorb the energy of the star, and we'll simply lose all heat and light. The Earth will cool down, delving into eternal darkness. But, like anything else, jets can do good things too. Like fertilizers helping crops to grow, the energy of the rays squeeze the space clouds, and new stars will be born from them. Imagine a drain in the bathroom through which water flows into a pipe. The water moves in a spiral, and some of it rotates around the hole. Now imagine that the black hole is the same drain, and instead of water, there's the stuff called plasma. It spins rapidly, gets magnetized, and collects into a huge accretion disk. Plasma starts to glow, and at some point shoots two streams into space. The black hole V404 Cygni lies 8,000 light-years away. It's like a firework display that weighs as much as 10 suns. The problem is, they forgot to install it securely, and the wick was prematurely set on fire. The hole is powered by gas from a nearby star. It provides infinite charges for the space fireworks. The V404 Cygni jets don't just fire from the poles, but in every direction. A disk as wide as 7 suns is spinning around the black hole. The inside of the disk is wobbling like a top that's about to stop spinning and fall. Scientists believe the wobbles and random shots are caused by distortions of the space-time continuum. Black holes are not the only ones who know how to put on a space show. Their main competitors are gamma-ray bursts. Science doesn't know exactly how they appear. Most likely, it's because of the decay of a huge star or the collision of neutron stars. Satellites record one gamma-ray burst every day, but at least 500 outbreaks occur in the universe within the same time period. An amateur astronomer first seeing the observable universe may feel like a movie star on the red carpet. Only they'll be blinded not by the lights from the cameras of journalists and fans, but by constant gamma-ray bursts. If there is a flash near the Earth, our planet will feel like a candle in a snowstorm. Imagine that you live in the future and can take off on safe interstellar flights. On your spaceship, you fly to a planet that looks like Earth to see a gamma-ray burst with your own eyes. Your ship is cutting into outer space and landing on the planet in question. As soon as you step on its soil, though, you feel it. Every living thing in this world is waiting for something terrible to happen. Frightened birds are flying through the sky. Animals start running out of the forests and looking for shelter. The wind makes the leaves rustle, and it's like they're whispering to you, "Save yourself, get out of here." Then, the wind grows stronger and turns into a storm. A bright flash appears on the horizon. After a few seconds, the light intensifies. Someone huge has turned on space floodlights. Everything is lost. There is only light. As much energy is released in 1 second as our sun generates in 10 billion years. 10 seconds pass and the show is over. The planet is moving through space, and the flash has only hit a part of its southern hemisphere. But that's enough for things to go badly. The gamma ray burst was a pretty short one, so it probably wouldn't have vaporized the oceans or blown away the atmosphere. But the ozone layer, which protects the planet from the rays of the nearest star and cosmic radiation, still disappears. All life in this world abruptly ends. The picture is terrible, but there's no need for us to panic just yet. Scientists believe the probability of a similar catastrophe on our planet is 0. But the Earth hasn't always been so lucky. The Ordovician extinction occurred 450 million years ago. Perhaps a gamma ray burst was to blame. Its epicenter was 6,000 light-years away from Earth. Harmful UV light hit the planet's surface, reducing the ozone layer by 40%. More than half the plants and animals disappeared. But life continued to develop, and after 200 million years, dinosaurs began roaming the planet. Eta Carinae is a hypergiant double star. It's almost 200 times heavier than the Sun, and in 10 seconds, it emits as much light as the Sun in a year. It's as far as 7,500 light-years away from Earth. But in 1843, dwellers of our planet saw it in the night sky without telescopes. This was possible thanks to an explosion. These beautiful clouds of gas and dust are the consequences of those events. We can say these are huge ruins of a star, but they look cool. Over the next 1 million years, Eta Carinae will continue exploding and form a gamma ray burst. But even here, humanity needn't worry. The direction of the gas clouds indicates that the future burst beams won't hit the Earth. Our planet is under siege. Right now, 30 million space objects, varying in size from a grain of sand to a car, are flying towards the Earth. But our atmosphere burns all border violators. Scientists are constantly monitoring space, and they haven't found a single space rock potentially hazardous for humanity. But this doesn't mean it doesn't exist. A huge asteroid arrives to Earth once every 2 million years on average. Here are the surfaces of the Moon, Mars, and Mercury. Craters cover them like cheese holes. These are the tracks of asteroids that have been bombarding their surface for millions of years. An atmosphere is an excellent barrier against the rock shower from the skies. But every year, around 500 large objects still make their way through it. Most of them fall into the ocean or sparsely populated areas and remain unknown. Geological activity continues on the planet. The continents move, mountains rise and fall. As you watch this video, the landscape of the Earth is changing. All of this erases all traces of meteorites that have fallen on the planet.
Somewhere, deep underground in super-secret laboratories, scientists are trying to create a black hole. It looks like the latest experiment was a success. The black hole hovers above the desk for a moment, but then, in a split second, it swallows it whole. Uh-oh. After its meal, the black hole grows until it is out of control. Microscopes and test tubes fly into the dark void. Soon everything in the room has been consumed. Each time it eats, it grows bigger and bigger and attracts even larger objects. On the surface, people go about their day as usual. Some joggers stop their run when they see a giant black sphere growing in the distance. Houses are torn from their foundations, and cars fly through the air towards the black abyss. In just a few minutes, the black hole has enveloped our entire planet. Then it grows big enough to consume the Moon and Mars. The black hole is now heavier than anything in our solar system. All of the planets begin to circle it before becoming food for the monster. Finally, even the sun is extinguished in the belly of the beast. Well, that was pretty bleak. Don't worry, this isn't how the scenario would play out in real life. Our scientists may actually be capable of creating a black hole, but it's far safer than this. The effort to make a black hole is led by the scientists working in Geneva on something called the Large Hadron Collider. This machine basically makes particles move at high speeds until they collide. When this happens, they release a lot of energy and create a lot of interesting effects. Scientists think that energy released by these collisions might be enough to create a black hole. Some people were so worried by this that they even tried to ban the construction of the Large Hadron Collider. Luckily, if a black hole did appear, it would be so small that it wouldn't be able to do anything. Black holes actually produce a lot of energy and release it, often as heat like a furnace. That means that they will fade away when they run out of fuel. If one appeared in the experiment, it would instantly burn out and disappear in a billionth of a second. Even if a stable microscopic black hole was created, it would grow so slowly that nothing would happen. Assuming that it survived long enough to absorb the tiny particles around it, a black hole of this size would take about 500 billion years to gain a pound of weight. Black holes could actually be really useful. One with the mass of Mount Everest would emit enough energy to completely power humanity. Even better, black holes are so dense that the one this big would only take up a tiny bit of space. We couldn't create anything as enormous as the naturally occurring black holes, though. Some can weigh hundreds of thousands of times as much as our Sun. Recently, scientists have observed a real black hole feast. The sight of a black hole tearing an enormous star apart is one of the most mesmerizing sights in the universe. Heavier and more destructive than anything else in existence, the black hole is both amazing and terrifying. And black holes aren't actually black at all. They're so massive that even light can't escape their pull, meaning that they're actually invisible. Scientists can only find them with special instruments. Most natural black holes are born as stars reach the end of their lifespan. You can picture healthy stars as giant furnaces that burn hydrogen and give off unbelievable amounts of energy. Every second, stars like our Sun produce more energy than humanity has ever produced, which pushes outwards and makes it want to expand. This is what eventually finds its way to Earth as the heat that birthed life on our planet. The only thing stopping this expansion is gravity, a force that basically just pulls objects toward something heavy. Most people know gravity is something that keeps us planted to the ground and stops us from flying off into space. The force of gravity of a star is so strong on stars that it makes them want to implode in on themselves. So, when a star is healthy, the force of gravity pushes inwards, and the energy it releases tries to inflate it like a balloon. These forces mostly cancel each other out and stop it from doing much at all. When a star burns through its fuel, though, nothing is pushing outwards to stop it from collapsing in on itself. Some really big stars make so much energy that they gradually expand into something called a red giant. When they run out of fuel, they cool, and gravity pushes the enormous object into a tiny space. Scientists use our Sun to measure how big things in space are. Our Sun weighs 1 solar mass. If a light star, like our Sun, implodes, not much happens, which is lucky if you've ever worried about being swallowed up into a black hole. If a red giant around 10 solar masses implodes, though, some incredible things can happen. The collapse of one of these is so intense that it explodes into a supernova, releasing a light as bright as the entire galaxy. Stars that are massive enough to produce supernovas sometimes become black holes. Their weight causes gravity to push down and compact them until they collapse into a black hole in less than a second. The inside of a black hole is mysterious and unexplored for obvious reasons. One thing we do know is that they're so massive that they can even distort time. 1 second near the black disk can be equal to weeks or even months on Earth, depending on its size. In 2019, scientists watched a black hole devour a star the size of our Sun. Even though it was 860,000 miles wide, the star was completely trapped in the black hole's gravitational field. For a while, they danced around each other, gradually coming closer and closer. Eventually, though, the star was extinguished in the invisible mouth of the black hole. The black hole sometimes releases beams of energy into space. Sizzling plasma flies out at 6,200 miles per second as the black hole finishes destroying the star. About half of the star's mass is consumed, while the rest is ejected into space. Incredibly, these insatiable titans even consume other black holes when they get big enough. The collision of 2 black holes was recently witnessed by scientists when one, weighing in at 85 solar masses, met another that was 66 solar masses. When black holes interact, the bigger one always swallows the smaller, adding even more mass to itself. The resulting black hole here reached 142 solar masses big. It's hard to believe, but this is still very small for a black hole. It will continue to consume everything around it and might even reach the size of a supermassive black hole at some point. These are unbelievably big and destructive. Our entire galaxy, the Milky Way, rotates around the gravitational field of one of these supermassive black holes. This monster weighs around 4 million solar masses, or more than 1 trillion times our planet. And that isn't even the biggest they get. It's also theorized that black holes can be made without a dramatic explosion. Big gas clouds that weigh hundreds of thousands of solar masses could condense under the force of their gravity to make a star. This object would already be so heavy that it would continue to compact until it became a black hole, skipping the supernova stage. Supermassive black holes are so far away and hard to observe that scientists doesn't have a full understanding of them yet. We don't know much about what happens inside a black hole, leading to a lot of speculation. For decades, people have theorized about how we could use black holes. Knowing that black holes distort time means that someone could use it to travel to the future with the right technology. If it was possible to build a ship strong enough to withstand the powerful gravitational fields, it would be simple. All they would need to do is decide how far they want to go and fly around the outside of the black hole. In the few minutes or hours they spent near the time warp, years could have passed back on Earth. They could be thousands of years old without having aged at all physically. Wow, that's officially a mind-blower. Okay, here's the deal. Something is bound to happen that can affect everything we've ever known about space and time. You've heard about black holes, right? That denser-than-life type of phenomenon that usually exists in the center of galaxies? 2 of them, located 9 billion light-years away from Earth, are expected to collapse into each other. And my oh my, I do not want to be around to see that. Let's get one thing straight. Black holes are the most powerful things in the entire universe that we know of. If they decided to go all Revenge of the Sith on us, we'd be doomed. A black hole was once a massive star that went supernova, meaning that the star collapsed onto itself, and the sheer magnitude of the explosion created a black hole in its place. Oh, by the way, black holes do not pull things inside like a vacuum cleaner. That's just a popular myth. Say we were to replace our Sun with a black hole at the center of the solar system. Not much would change, except that maybe we'd all freeze. Yep. But black holes can do something much worse than vacuum stuff. They can delete the universe itself. If a black hole was to follow a normal timeline, it would go from its creation to total disappearance. But this process is very, very slow. I'm talking about billions and billions of years before a black hole loses its mass entirely. That happens because they're constantly losing their mass every single second. Black holes radiate their mass away, like a boiling teapot loses its water as steam. Yet, things rarely go as planned, both in our lives and apparently in the universe itself. So it wouldn't be that much of a surprise to find out that two black holes are en route to collapse. That's what scientists have found out recently. And let's just say that this is one of the reasons why the scientific community is freaking out just a little bit. The first question that comes to mind is, what does that mean for us humans? Total annihilation? No need to be this dramatic. The best case scenario, we'd be in for an interstellar type of experience. Roll me in, please. Let's rewind a little bit to understand how this would happen. 45 years ago, a group of scientists began noticing a weird behavior coming from a galaxy far, far away. The galaxy is found 9 billion light-years away, and its scientific name is a mouthful, but let's just call it Super Far Away Galaxy. You might be asking yourself, well, how did scientists observe this black hole so far away if it doesn't emit any light? Good question. That's because black holes gather disks of gas around them, and they emit some of this material into space. These jets can be detected from a distance of millions of light-years. Now, if these hot gas jets are directed towards space, then scientists give these black holes a special name, blazars. A particular blazar has been gaining worldwide attention recently. Long name, but let's just call it Andy. Imagine you're a scientist at Caltech and you're looking at a blazar in your radio telescope and you notice its strange behavior. Its brightness goes on and off, like the ticking of a clock. At first, you don't understand what's happening over there in a distant corner of the galaxy. But then, you realize there must be another black hole circling the first one. In other words, scientists discovered that Andy was being orbited by another blazar, Gomer. And the regularity of their twinkling can only mean they are close to a total collapse. It gets worse. Each of the two blazars is estimated to be a few 100 million times the mass of our Sun. Have you seen our Sun? It's huge. It's already 333,000 times the mass of our Earth. This means we're destined to face something out of our league. Now, this is not the first time scientists have detected something like this. In September 2015, the LIGO Observatory detected a collision of two black holes. Each of them was as heavy as 30 suns, and an equivalent of 3 solar masses was released once they crashed into each other. And guess what? This gravitational wave passed through Earth at the speed of light. But we really weren't affected by it. Maybe you were sleeping and felt something weird in the air, but nothing significant happened to us as a species or to our planet. But that's because the blast was weak. The thing is, the expected collision between Andy and Gomer will send unprecedented gravitational waves throughout galaxies, and they will reach the solar system. But what is this shock wave actually capable of doing? Well, it could stop our Sun from releasing gas for a few minutes, which means it would stop heating the solar system. So, let's say you were going about your summer day, and out of the blue, the atmosphere froze for a few seconds. Doesn't sound too nice, huh? But that's actually a better possibility than the next one. In one of the worst-case scenarios, a blast from the collision between Andy and Gomer could break bonds between atoms and make everything disintegrate. You, me, your cat, we'd all turn into flying particles floating in the vacuum of space. This may sound scary, but scientists say that an atom is made out of 99% empty space. This means that everyone on this Earth, all 8 billion of us, and everything that exists, planets, objects, animals, are all made up of 99% empty space. So perhaps all that Andy and Gomer would do is separate all of our atoms and desolidify us. Then again, the blast could mess with the fabric of space and time as we know it. You remember Albert Einstein, right? Crazy hair? He's the name behind the theory of relativity. Einstein discovered that time is relative. It's always dependent on the observer. This would mean that time is not the same throughout the cosmos. Why though? Well, because Einstein's theory of relativity is also a theory of gravity. Einstein discovered that gravity is the effect that objects have on the fabric of space-time. Every object that has a mass, including you, me, your cat, and our planet, creates a warp or a distortion in the fabric of space-time that causes it to bend. The bigger the mass, the bigger the gravitational force, and the bigger the distortion on the fabric. It may sound complicated, but hey, this is what creates different perceptions of space and time throughout the cosmos. This is why you'll age differently on Earth and on Jupiter. This is why time passes completely different for astronauts on long missions and for people that remain on Earth. And this is why a collision of two mega blazars could mess with our perceptions of space and time due to the sheer force of its gravitational shockwaves. Got it? Not to mention that black holes are already a huge warp in the fabric of space-time. You remember that interstellar scene, right? Where the lead character bends the space-time continuum through a black hole? Now, don't try this at home though. As far as we know, anyone who chooses to go inside a black hole has no guarantee of making it home again. Scientists say that this blazar explosion will happen in approximately 10,000 years. But wait a minute. If this blazar lies 9 billion light-years away from Earth, it means that these two black holes should have already collided long before our solar system and home planet were born. You see, the solar system was born around just 4 billion years ago. And since it takes us 9 billion light-years to receive the light emitted from the blazars in the first place, this means that the collapse of the two blazars already took place, and it'll reach Earth 10,000 years from now. This means the shockwaves are already making their way through the galaxies at this very moment. But still, it's not something even your great-great-great-great-great-great-grandchildren will be around to see. Imagine a black hole, a terrifyingly dense space object pulling inside everything that comes too close. Nothing can escape its clutches, even a beam of light. And now, imagine two of these space monsters colliding. Scary? You bet. Astronomers have spotted two supermassive black holes feasting on the cosmic material of two merging galaxies in distant space. This phenomenon is the closest to colliding black holes we have ever seen. Supermassive black holes are the largest among all black holes out there. Their mass can be hundreds of thousands or even millions to billions of times larger than that of our suns. And two such giants have been recently spotted with the help of an array of telescopes in northern Chile's Atacama Desert. Astronomers originally used these telescopes to watch two merging galaxies located approximately 500 million light-years away from Earth. Thanks to being alert at all times, scientists have also noted that two gigantic black holes were growing alongside of each other. Apparently, these black holes came across each other when their host galaxies collided. One of the black holes is around 200 million times the mass of our Sun, and the other is a bit smaller, only 125 million times larger. Now, we can't see black holes directly. If you were to travel to a black hole, you wouldn't notice it until it was too late. The only detail that would give away the approaching black hole would be a slight blurring of distant stars due to the hole's gravitational lensing effect. The two black holes we're talking about are no different. They aren't visible directly, but are surrounded by bright clusters of warm glowing gas and stars. All of this has been tugged close by the black hole's gravitational pull. Time will pass, and these black holes will start circling each other. And eventually, they will collide, creating one, probably even bigger, black hole. Scientists have been observing these black holes across multiple wavelengths of light and have come to the conclusion that they are unique. They're located the closest to each other astronomers have ever seen. The distance between them is a mere 750 light-years, which, astronomically speaking, is just next door. Even more exciting, this distance is close to the limit of what modern technologies can detect. The thing is, such ginormous merges are more typical for distant galaxies. This makes it harder for Earth-based telescopes to see them. But the sensitivity of ALMA helped astronomers observe those bright and compact regions where matter swirls around the black holes. Imagine how surprised astronomers were when, instead of one black hole, they discovered two of them, munching on the dust and gas stirred up by the massive space merger. Galaxy mergers are way more common in the distant universe than in our neighborhood, and this discovery may mean that such black hole binaries are likely to be much more common than we previously thought, too. And if pairs of black holes are so common, it might make it easier for us to study gravitational waves. These waves, also known as ripples in space-time, occur when black holes collide. If we talk about the recently discovered pair of black holes, it might still take them several hundred million years to crash into each other. But by observing their behavior, scientists can figure out how many binary black holes there are that are about to collide in the universe. Also, this may give us more insight into what is going to happen when our home Milky Way galaxy collides with the Andromeda galaxy in around 4.5 billion years. By the way, the first photo of a black hole was taken in 2019. An international team of scientists, consisting of more than 200 astronomers, had been working for years to get this result. And their efforts finally paid off. The object in the photo is about 55 light-years away from Earth at the center of the galaxy M87. You can now admire this amazing space phenomenon thanks to the work of a vast global network of telescopes called the Event Horizon Telescope Collaboration, or simply EHT. The event horizon is a point of no return on the outskirts of a black hole. When something, for example, matter, radiation, or light, reaches this boundary, there is no way for it to escape. To capture the very first image of a black hole, scientists created a virtual telescope that turned out as big as our planet by combining the power of 8 radio telescopes. But it wasn't an easy feat. The researchers had to simultaneously point the telescopes in a meticulously planned order with the help of precise atomic clocks set on each telescope. Plus, they were constantly monitoring the amount of moisture in the air, since too much humidity would ruin the images. To keep the chances of rain to a minimum, they even constructed the telescopes in super dry regions, such as the Atacama Desert in Chile and the South Pole. All in all, the process resembled a carefully coordinated dance. But thanks to these preparations, in over 2 weeks, the telescopes collected 5,000 trillion bytes of data. It was then processed by several supercomputers, and scientists finally got the long-awaited images. And what they observed was a monster of a black hole measuring about 25 billion miles across. Now, how about we talk about the coolest black hole facts? There are baby black holes called primordial, and they're really tiny. They vary from the size of an atom to that of a mountain. There is a theory that galaxies get formed around black holes. This means that when a large star explodes, a black hole appears in its place, and then the rest of the galaxy just forms around it. There is a supermassive black hole right in the middle of the Milky Way galaxy. Its name is Sagittarius A star, and it's 4 million times as heavy as the Sun. And nope, we're not going to be pulled into this hole. It's more than 26,000 light-years away from Earth, and that's too far for this monster to have any influence on our planet. Besides Sagittarius A star, there are 100 million medium-sized black holes in our galaxy. And can you imagine how many black holes in total there are in all 100 billion galaxies that exist out there? Nah, you do the math. If you ever find yourself near a black hole, be ready that time will slow down significantly. It may work for you if you aren't so eager to grow older. Just don't let yourself be tugged into the event horizon. Whoops, bye-bye. Black holes aren't some hungry predators that roam the universe preying on poor, unsuspecting planets. They just gulp down the stuff that ends up too close to them. On top of that, they sometimes fling out spitballs the size of a planet. How does this matter escape the pull of black holes? Well, typically, it manages to slip away before going past the point of no return. In fact, with Sagittarius A star, we should be worried not about its gravitational pull, but about the very spitballs. After all, the monster black hole hurls them in the direction of Earth at a speed of 20 million miles per hour. What if, one day, one of them reaches our planet? If you managed to squeeze Earth to the size of a cherry tomato, it would turn into a black hole. In fact, you could also become one if you agreed to be scaled down to an atom. South African astronomers have recently come across another head-scratching black hole mystery. In a region of distant space, they noticed that several black holes, located in different galaxies, aligned in the same direction. It looks as if their gas emissions have been synchronized by design. Nowadays, scientists can't explain why and how black holes, which are about 300 million light-years away from one another, can be acting in unison. It's a puzzlement.
Imagine a powerful giant, like the Sun, clashing with a tiny yet mighty opponent, a small black hole. The collision is imminent, and the fate of the solar system hangs in the balance. Will the Sun be able to withstand the intense gravitational pull of a tiny black hole, or will it be swallowed whole? The answer lies in the forces at play in this mind-blowing cosmic collision, so let's break them down. First of all, what is a black hole? A black hole is a region of space where the gravity is so strong that nothing, not even light, can escape from it. Like a cosmic vacuum cleaner, it sucks up anything that gets too close. It's so massive that it warps the fabric of space-time around it. Black holes are one of the most scary and mysterious objects in the universe, a powerful force of nature that defies our understanding of physics, a true enigma of the universe. Black holes come in different sizes, from small ones that are only a few miles wide, to supermassive ones that are billions of times the mass of the Sun. Most of them are formed by the collapse of massive stars. After the black hole is born, it starts to grow in size by eating everything in its path. And if two or more black holes collide with each other, they can merge into one enormous cosmic monster in a terrifying dance. But what about the smaller ones? The smallest known black holes are called stellar black holes. It's a type of black hole that weighs 3 to 10 masses of our Sun, while being very small. It's like taking all the matter in the solar system and squeezing it into something the size of New York City. And yes, it's considered very small. Just for comparison, intermediate mass black holes weigh between 100 to 1,000 solar masses, and supermassive black holes weigh millions or billions of solar masses while being unimaginably huge in size. So, stellar black holes are basically nothing compared to their relatives. Imagine a massive star, bigger than our own Sun and with a heart made of nuclear fuel, burning bright and hot. But as the star runs out of fuel, gravity takes over and starts to squeeze the star. The more it squeezes, the hotter it gets, until the star's core reaches a temperature of billions of degrees. Eventually, the core collapses under its own gravity. This creates a massive blast called a supernova. This collapse creates a singularity, which means a point of infinite density and gravity. This point is surrounded by an event horizon, the invisible line beyond which nothing, including light, can escape. And just like that, voila! A stellar black hole is born. Pretty mind-blowing, isn't it? Stellar black holes are the most common type of black holes we know of. These guys can be found all across our galaxy. So, what are the chances that such a little monster will come for our Sun? And in that case, what will happen to us? Well, actually, the likelihood of the Sun colliding with any black hole is incredibly small. It's almost impossible for it to happen. Even though stellar black holes are the most common type of black holes in our universe, they aren't common at all. The chances of the Sun and some black hole crossing paths is so rare, it's basically like winning the intergalactic lottery. Only this win wouldn't be that pleasant. For 2023, the closest known black hole in our solar system is Gaia BH1. It's about 10 times heavier than our Sun, and even this one is about 1,600 light-years away from us, which is a quadrillion miles. So, it's safe to say that our Sun is not going anywhere anytime soon. But never say never, right? Just like with any astronomical event, we need to understand the different ways something like this could happen. For example, it would be possible if a rogue black hole passed through our solar system, much like a comet or asteroid passing by. Unfortunately, unlike comets and asteroids, black holes are invisible and can only be detected by their gravitational pull. So it's not like we'd see a big, ominous black hole hurtling towards us. Rather, we'd only know it was there if it caused some sort of disturbance in the orbits of nearby objects. So what now? We know that the Sun is a massive, luminous star at the center of our solar system. It's about 4.5 billion years old and has enough fuel to last for another 5 billion years. This star is so big that it's hard to even comprehend its size. In fact, if you were to put all the planets in our solar system inside of it, there would still be room for more. And it's so massive that it contains almost 100% of the total mass of the solar system. So it's hard to imagine how some insignificant small black hole thousands of times smaller than this star can devour it. And you're right, it won't. Well, at least not completely. So imagine if a rogue black hole arrived in our solar system and has begun to approach the sun. As it gets closer and closer, the black hole's immense gravity will start to pull the material from the surface of the sun. The sun would start to get stretched and distorted. This is called spaghettification. Imagine a rubber band being stretched until it snaps. That's kind of what would happen to it. This gathered material will form a swirling disk around the black hole, called an accretion disk. As more and more material is pulled in, the disk will heat up and start emitting intense radiation. And as the sun gets pulled in, it would start to release massive amounts of energy in the form of light and heat. The sun would become much brighter and hotter than before. The sun's outer layers would be vaporized, creating a massive cloud of gas and dust that would expand outwards. It would be like a cosmic fireworks show, but with terrible consequences. Even though it would be one of the most spectacular views in the universe, we wouldn't be able to see it. As you might have guessed, the Earth would be in for a really rough time. The intense radiation and solar material would cause massive wildfires, and the intense heat would vaporize the oceans. The Earth would be bathed in a constant stream of high-energy particles, and the atmosphere would be ionized. In short, the chances of any life surviving would be close to zero. And this collision would have far-reaching consequences not only for the Earth, but for the entire solar system. The intense radiation and heat would vaporize everything in its path. All the planets would be destroyed. Now, the sun being a larger object than a typical star wouldn't be completely devoured by the black hole, but it would be significantly distorted and disrupted. The intense gravity of the black hole would cause the sun's outer layers to be pulled away, creating a massive blast called a tidal disruption event. But either way, in the end, the black hole would win. It would grow in size, and a new accretion disk would form around it. As we've seen, the collision of the sun with a black hole, whether it be a tiny or stellar one, would be an epic and catastrophic event. But thankfully, as we've already mentioned, the likelihood of such a collision happening is extremely low. However, that doesn't mean we should stop studying black holes and their potential impact on the universe. The more we learn about these mysterious objects, the better equipped we'll be to understand and predict their behavior. So, let's keep researching, exploring, and observing the depths of space. And who knows, maybe one day we'll come across a black hole that's just too curious and gets too close to the sun. Let's hope by that time, we will already be living on other distant planets. Black holes are massive, the densest objects in the universe. They have such a great mass that their gravitational pull doesn't let anything, even light, escape their clutches. But in this terrifying world of black holes, there are monsters that are in a league of their own. Recently, astronomers discovered a black hole that is 33 billion times as heavy as our Sun. This space giant sits at the center of a supergiant elliptical galaxy called Abell 1201, which is located 2.7 billion light-years away from our planet. This black hole is so large it was given a rare designation, an ultra-massive black hole. No wonder. It's more than 8,000 times heavier than the supermassive black hole at the center of our home Milky Way galaxy. This ultramassive black hole was the first one to be discovered with the help of gravitational lensing. This method is based on the fact that very massive objects such as galaxies bend the light from a more distant object, magnifying it. A great thing about this method of research is that it allows astronomers to study inactive black holes too. It could help us detect loads of new black holes beyond our universe. That's what the area surrounding our galaxy is called. Probably it would help us find some exotic objects we've never seen before. Now, let's speak about another awesome instrument that efficiently helps us explore space, the James Webb Space Telescope. When it stares at young galaxies, which would look like mere red specks to you, it sees an astonishing number of cyclones churning at their centers. Those are black holes. Interestingly, giant black holes were believed to be big players in early cosmic history. But James Webb regularly finds an unexpected number of these beasts. For example, using the telescope, astronomers have detected a supermassive black hole from when our universe was less than 600 million years old. In universe terms, it's just a baby. This is the most distant actively feeding supermassive black hole ever observed. It's located at the heart of its host galaxy called Sears 1019. The black hole is surprisingly small and not massive at all. It's actually one of the smallest found in the early universe. It's equal to approximately 9 million suns. It might sound like a lot, but in reality, supermassive black holes tend to grow to billions of times the mass of our star. There's another unusual thing about this find, and scientists are having a hard time trying to explain it. You see, it's supposed to take way longer than 600 million years for a supermassive black hole to grow to its full potential. The development happens when a black hole either feasts on surrounding matter or merges with a larger black hole. Even black holes similar to the one at the center of our Milky Way galaxy, which is almost 4.3 million times the mass of our Sun, are supposed to be seen in the more recent universe. Actually, scientists have long suspected that supermassive black holes probably existed in the early universe. But this theory has been proven only thanks to the JWST and its infrared eye. It's shown that the black hole Sears 1019 is actively munching on all the matter it can lay its hands on. Such feeding black holes are usually surrounded by swirls of gas and dust, falling inside them, called accretion disks. The gravitational force of a black hole heats this matter, and it makes the disk shine. And that's not all. Extra strong magnetic fields produced in this process channel the matter to the poles of the black hole. From time to time, this matter is released into space in twin, powerful jets. They move at a speed that is close to the speed of light, which generates incredibly bright light. Astronomers were watching the galaxy hosting the unusual old black hole as part of the Cosmic Evolution Early Release Since survey. They saw the galaxy as it was when our 13.8 billion-year-old universe was just 570 million years old. Besides the super old black hole, scientists spotted two other ones. Those probably appeared 1 and 1.1 billion years after the Big Bang. They also discovered 11 ancient galaxies that existed between 470 and 675 million years after the beginning of cosmic history. Now, how about having a look at the biggest black holes astronomers have found so far and finding out what would happen to Earth if one of them was to enter the solar system? NGC 6166 is a monster that has grown to have a mass of 30 billion solar masses. It's an elliptical galaxy that has an active nucleus at the center. It's also one of the most luminous sources of X-rays. The galaxy's supermassive black hole powers two symmetric radio jets in the opposite direction, which is the result of the infall of gas into its center. Another peculiar thing about NGC 6166 is that it shows a blue shift, which means it's moving towards us. Is it time to pack up and move out of our solar system? The next supermassive black hole is located in the constellation of Draco, approximately 10.4 gigalight-years from us. The mass of this supergiant is more than 30 billion solar masses. Besides being incredibly massive, the black hole is also really big. If it replaced our Sun, the diameter of this hole would extend to the orbit of Pluto. The next black hole is one of the most interesting on our list. It has a mass of 40 billion solar masses and is actually a blazar. It's the most energetic of all quasars, super bright distant objects. The blazar's luminosity is 300 trillion times that of the Sun, and more than 25,000 times as great as the luminosity of all 100 to 400 billion stars of the Milky Way galaxy combined. But since the distance to this quasar is about 12.1 billion light-years, we can't see it directly. But we know that the central black hole of the quasar consumes huge amounts of matter, about 4,000 solar masses of material every year. IC 1101 is a supergiant elliptical galaxy. It's the most massive known galaxy so far. Since this galaxy is elliptical, it isn't filled with gas. That's why the star formation in that region is very low. As for the black hole at the center of this galaxy, it lies in the mass range of 40 to 100 billion solar masses and emits clear radio signals. But wait for this champion. Astronomers have discovered a gravitational space wonder that has grown to really unimaginable proportions. The black hole I'm talking about is TON 618, and it's a mind-boggling 66 billion solar masses. Yep, we've got another ultra-massive black hole here. Imagine gathering all the stars in our home Milky Way galaxy and squishing the matter they're made of into one black hole. And it still won't be enough to create a TON 618. If this monster of a black hole replaced the Sun, its radius would be more than 40 times the size of Neptune's orbit. You know that black holes are incredibly dense, but it doesn't mean they're some kind of space predators roaming galaxies and munching on everything they come across. TON 618, for example, still has a whole galaxy filled with stars and other stuff happily orbiting it without getting pulled inside. So the perception of black holes as giant vacuum cleaners is wrong. In reality, it's incredibly hard to grow a black hole. Try and you'll see. And now, what if a supermassive black hole, like the one that dwells at the center of our home Milky Way galaxy, moved a bit closer to our solar system? The answer is simple. We'd be doomed. The distance between this huge thing and Earth would be several dozens of light years, and still, it would wreak total havoc on our planet. Earth, along with other objects making up the solar system, would be tugged into the black hole's orbit and doomed to spin around it for eternity. But you can relax and breathe out. Such massive black holes stay away from us at the moment.
Stellar mass and intermediate mass black holes form when huge stars can't support nuclear fusion anymore and collapse, unable to withstand their own gravity. But it's not so clear with supermassive black holes. The mechanism of their formation is still unknown, since there seem to be no stars large enough to directly collapse into such a giant black hole. Nearly every large galaxy has a supermassive black hole at its center, and our Milky Way isn't an exception. We've got Sagittarius A, which is pronounced Sagittarius A star. This space monster is mostly dormant and rarely wakes up to munch on gas and dust, and still, its mass is millions of times that of the Sun. To be precise, almost 4.5 million times. There are still lots of mysteries surrounding this black hole, but one of the most recent discoveries can also be the most exciting. But we'll get there later. Right now, imagine a distance of 14.6 million miles. It's like about 61 distances from Earth to the Moon. That's the diameter of our supermassive black hole. Of course, it will look tiny compared to the Milky Way itself, which is 100,000 light-years wide and 1,000 light-years thick. But it's still impressive. At the same time, Sagittarius A is dwarfed by a disk of gas surrounding it. It extends for a whopping 5 to 30 light-years and occasionally feeds the black hole. When it happens, faint flashes of X-rays are produced. The disk, known as the accretion disk, is also responsible for X-ray emissions triggered by friction. This friction can make the temperatures inside the disk go as high as 18 million degrees F. And now the coolest part, the supermassive black hole at the heart of our galaxy is not just spinning, it's doing so at almost maximum speed, dragging everything close to it along for the ride. Scientists have calculated the rotational speed of Sagittarius A with the help of NASA's Chandra X-ray Observatory. Normally, the spin speed of a black hole is given a value from 0 to 1, with 1 being the highest rotational speed. Speaking of our supermassive black hole, its rotational speed is between 0.84 and 0.96. That's close to the top limit, defined by a black hole's width. Now, the spin of a black hole is very different from that of other space bodies. Solid objects, like planets, moons, or asteroids, have physical surfaces. But black holes are regions of space-time surrounded by an outer, non-physical surface. This surface is called the event horizon, and even light can't escape beyond it. The rotation of a planet or a star depends on the distribution of its mass. At the same time, the rotation of a black hole is governed by its angular momentum. The extreme gravitational forces next to a black hole cause space-time to become slightly curved and twisted. It forms what we know as the ergosphere. This notion is unique to black holes and never occurs around relatively solid space bodies like planets or stars. In other words, when black holes spin, they twist up the very fabric of space-time, dragging along the ergosphere and everything it contains. This phenomenon is known as frame dragging. Come to think of it, the name does make sense. Thanks to this dragging, we can observe weird visual effects around black holes. The theoretical maximum speed of a black hole is determined by how it grows after feeding on matter. As something falls into a black hole, it increases its spin. Plus, we should take into consideration the mass of a black hole. The more massive it is, the higher its gravitational pull is. And this makes it more challenging to increase the speed of the spin. Let me illustrate this idea. Our relatively not-so-heavy supermassive black hole, whose mass is equivalent to around 4.5 million suns, has a spin between 0.84 and 0.96, which is very fast. At the same time, a much heavier supermassive black hole at the heart of galaxy M87, which has a mass of 6.5 billion suns, is spinning just as fast, between 0.89 and 0.91. The solution to this mystery? This black hole is also feeding very rapidly, which allows it to increase its speed.
If you somehow fell into a black hole, it might change your future and erase your past. Well, at least theoretically. Let's start with the real world we live in. Here on planet Earth, your past can definitely define your future. But imagine you're not on Earth, but somewhere out there in the endless universe, and you stumble upon a certain type of black hole. The one that a UC Berkeley mathematician found. Not to mix it with a regular black hole. Let's call this type... what about a benign black hole, huh? So here's why you need a specific black hole. Thing is, you're highly unlikely to stay alive in a regular black hole. But according to some calculations made by a postdoctoral fellow, Hints, from UC Berkeley, this specific type of black holes we agreed to call benign ones might expand at an accelerating rate. This is what makes it possible to survive the transition from our deterministic world to a black hole, which is not deterministic. Let's imagine you survived that passage, and now you're moving towards the center of a benign black hole. It's impossible to picture what's inside, and if you, as a traveler, could actually get into a black hole, you'd never be able to communicate to the outer world what interesting things are hidden in it. But it's not what interests us for now. We need to know how to get rid of the past. Hints, the mathematician you already know, studies non-rotating black holes that have an electric charge. The most important thing about them is that besides the event horizon, they also have the Cauchy horizon. And here's the point. The Cauchy horizon is the place where so-called determinism simply breaks down. This may sound too scientific, but let me explain it to you. The Cauchy horizon is the place where your past doesn't determine your future any longer. So, here's a mathematically proven and apparently working method of how to get rid of your past. All you need to do is get into space, find a specific black hole, make it to the center, and get to the Cauchy horizon. However, if it sounds too complicated, you can simply try not to make mistakes here on Earth. Yeah, ideas like your past gets cancelled, you have an infinite amount of options of how your future will evolve, and all that jazz sounds as unrealistic as they are appealing. Like, imagine no one knows you failed to get into college and get a degree, but from now on, you have every opportunity to do whatever you want. But only theoretically. In reality, once you get into the black hole, not that specific one we've already talked about, you're most likely to disappear once and for all. But hey, don't be sad. I'm only talking about your current physical form. It's a bit deeper than it might seem. Thing is, there's a curious principle of quantum mechanics that can be explained in a simple way. For starters, imagine that you're not a human being, but just information. You have your experience, your background, and your thoughts. All of these are the information you are. Now, let's make it even simpler. Imagine a USB drive or a book. Both of these things contain information. If you smash a USB drive that contains music and movies, it won't exist anymore in its physical form, but the information it had will never stop existing. Same with the book. If you burn it, the information it has doesn't get burned. It continues to exist, but in another form. So, this fun theory claims that even though someone passes the horizon of events, which is a point of no return before you get spaghettified, they don't stop existing. In simple words, these universe travelers still exist, but in the form of information. Now let's go back to the black holes. According to Stephen Hawking, black holes emit radiation. Radiation makes them shrink, and with time, I mean much time, a black hole can shrink so much that it eventually disappears. So what happens to the astronaut who got entangled in a black hole if it disappears? Nope, they won't be ejected from the black hole in the way they used to exist. However, they will still be ejected from there, but in the form of Hawking radiation. But it's just a theory. Right, you remember that no one knows exactly what happens in the black hole? Another theory says that what happens in the black hole doesn't really stay in the black hole. Sounds like a good alternative to Las Vegas if all the flights for the weekends have been booked. Some scientists believe that a black hole might have a portal where you can turn back time. According to this theory, there's a white hole at the end of a black hole. If you get there, you can undo things. Like, you broke your mom's favorite vase? Hop into the white hole and it'll be as good as new there. You cooked a scramble and made a fresh orange juice, but somehow lost your appetite. It's not a problem if you cook it inside a white hole. Voila! The eggs are unbroken. The oranges are uncut and juicy again. No more food waste. Alright, turning back time sounds really cool, so I guess we might actually need a black hole to help us out. If a black hole was made in a, let's say, lab, it could devour things until it grew big enough to consume the entire planet. First, it would munch on the Large Hadron Collider, which might possibly create something similar to a black hole here on Earth. Next, Geneva, where the Large Hadron Collider is located. Then the whole country of Switzerland, then Europe. At that point, it wouldn't be long before the Earth was gone too. Luckily, if a black hole did appear, it would be so small that it wouldn't be able to do anything. Black holes actually produce a lot of energy and release it, often as heat, like a furnace. That means they will fade away when they run out of fuel. Even if a stable microscopic black hole was created, it would grow so slowly that nothing would happen. Assuming that it survived long enough to absorb the tiny particles around it, a black hole of this size would take super long to get even a pound of weight. I won't be around then. But a black hole on Earth could be a great thing. Even a relatively small one may emit enough energy to completely power humanity. We're talking a lot about food, huh? Let's not forget about spaghettification. The concept is quite simple, by the way. It's all about gravity. Imagine you're playing with chewing gum. With your force, you could easily stretch it so instead of a regular piece, you can get a long and thin one. The same happens to you. Black hole force is enough to stretch you as if you were a piece of chewing gum. Gravity holds you tight on one side, which makes you stretch. You may wonder, how come you don't get spaghettified on Earth if there's gravity too? Easy peasy. It's just too weak to do that with you. If you asked a butterfly to stretch the gum, would it be able to do that? Not likely. Their tiny limbs are just too weak. Same here. The Earth is just too weak compared to a black hole. So, if you were wondering whether you'll ever reach 6'6", it may never happen on Earth. But once you're in a black hole, you can go far beyond those mere 6'6". Your best height moment won't last long though. If you stretch the chewing gum at one moment, it will simply tear apart. The same will happen to you because of spaghettification. You know how galaxies have supermassive black holes in their centers? In most cases, we don't have to be afraid they'll come after us. They stay at the same spot for eternity, or at least until they start to evaporate and give the energy they have stolen back to the universe. But there's always that one rebel that spoils the statistics, like this invisible beast that ran away, moving farther and farther from its home galaxy. It escaped with style though, leaving a shiny trail of stars behind it, like a wake behind a ship. And it's moving really fast. If it was somewhere in our solar system, the moving black holes could cross the distance between our home planet and the moon in a mere 14 minutes. A regular spacecraft needs 3 days to do that. The unusual space wanderer weighs as much as 20 million suns and has left a trail of newborn stars 200,000 light-years long, which is twice the diameter of our galaxy. No one has definitely seen anything like that before. There are a few ways a supermassive black hole can run away from its home. One of them is when two galaxies come together in a big collision. As they hit each other, you get a pair of supermassive black holes that start dancing in circles around each other. If there's one more black hole that decides to join the party, it can give a big push to one of the dancers and kind of catapult it far away from the center of the galaxy. Another way is when the two dancers finally catch up with each other, align their moves, and become so compatible they merge at one point. This new black hole they create can get a push or a kick, and before it even knows it, it's somewhere far, far away from the safety of its home. This runaway black hole we're talking about is probably the result of many collisions of giant black holes. Their home galaxies probably merged around 50 million years ago, which brought these two together. Then, an intruder likely appeared, another galaxy with its very own giant space vacuum, and things quickly became chaotic. As one of those three tried to steal the moment from the other two, it ended up thrown out of the galaxy. The original pair may have stayed there, or maybe the guest took the place of one of them. Don't think it's always that easy to go after the rebel and talk it into going back home. It's generally really hard to detect black holes. Sometimes, they give away their current position when they eat large volumes of stuff they find on their way, such as gas and stars. When they're full, they become very bright. But the rest of the time, they just eat a normal amount and hide in the eternal shadows of the cosmos. They leave traces when they come closer to objects in space. We may not be able to see black holes directly, but special telescopes can catch what they do to their environment. For example, we can observe a star that makes circles around something we can't see instead of orbiting its binary companion star as we'd expect. Scientists can measure how fast that star is speeding up and calculate the mass of the object that's pulling on it. And when the mass is so big they can't match it with anything they know about, it means it's probably a black hole. Also, special X-ray telescopes can recognize radiation emitted by a star that has come too close to a black hole, which is now pulling it apart with its strong gravity. Black holes have an accretion disk, which is like a swirling thing that orbits them, like a whirlpool. When stuff from their surrounding falls into this whirlpool, it gets very hot and starts shooting out X-rays. Supermassive black holes have a mass of over 1 million suns, so it's not surprising they shoot out gas particularly far into space, sometimes even millions of light years away. Anyway, our rebellious black hole was hard to spot, considering how it kept moving faster and faster. But unlike others, it's never tried to hide, considering that shiny trail of stars. It doesn't gobble up stars that are ahead of it. Obviously not a fan of Pac-Man. Poor fella doesn't even have time to stop and grab a quick bite. Instead, it's just plowing into gas in front of it, which triggers the formation of new stars along its narrow path. The gas probably cools and forms a trail that's nearly half as bright as the galaxy itself. The black hole sits at the top of the column that stretches all the way back to its parent galaxy. It seems like this Runaway wants to mark the way wherever it goes, in case it ever decides to get back home. And over there, at its tip, there's a glowing knot of ionized oxygen. It's probably there because it got shocked and heated from the black hole moving and hitting the gas. Or maybe this could be radiation coming from the accretion disk. This is not the only unusual black hole traveler that decided to take a different path in life. Astronomers have found another wanderer, a black hole, completely on its own for the very first time. Big stars can explode and turn into black holes, but in most cases, these black holes have star companions. When they come in a binary system, they interact with their partner so you can find them easier because of the light around them. That's why finding this solo traveler wasn't easy at all. It just didn't give off any light. But the Hubble Space Telescope did a pretty good job of finding how the gravity of this sneaky black hole bent light around it, similar to how a magnifying glass does. It's cool that we found something like this because it tells us there could be more of these loners that prefer traveling alone, hiding in the dark. These black holes sound scary, but the comforting thought is they're very far away. Take this lonely wanderer as an example. It's 5,150 light-years away from our home planet. But in 2020, scientists thought that they had found the closest black hole to Earth, only 1,000 light-years away from us. It was really big news until they realized they had actually fallen for an optical illusion. They thought there were 3 giant things over there. A big star making a circle around a black hole every 40 days, with one more star whose orbit went way farther. But it seems it was just a system of 2 stars orbiting each other closer than expected. But we've still got something cool to observe, because they're so close that one of the stars is pulling the atmosphere off the other. Yup, stars have their own vampires too. This vampire star is way bigger and spins faster than the other one. This results in an illusion that they're orbiting each other farther apart than in reality. Still, if I had to choose between these vampire stars and J114 in our galaxy, I'd definitely choose them. The latter one is a terrifyingly big black hole about 3 billion times heavier than our Sun. Our planet is not even a crumb in its morning bowl of cereal since it eats chunks of matter as big as the whole Earth every second. We're talking about the brightest and fastest growing black hole we've seen in the last 9 billion years. What's also fascinating is that this black hole devours matter so quickly that its boundary, which we call the event horizon, is really wide. You could easily fit all the planets of our solar system inside. The cool thing is also that its event horizon is so bright even amateur astronomers with good telescopes can see it if they look for it in the right part of the sky.
The James Webb Space Telescope has recently discovered the oldest black hole ever found. It's an ancient monster as massive as 1.6 million suns, and it's lurking 13 billion years in the past at the center of an infant galaxy. This supermassive black hole appeared a mere 440 million years after the beginning of the universe. But it's just one of the countless black holes that inflated to terrifying scales during the dawn of the cosmos. It's the period about 100 million years after the Big Bang. That's when the young universe started to glow for a billion years. This discovery of the universe's oldest black hole can provide astronomers with the answers to some vital questions. For example, how could these space whirlpools balloon in scale so fast after the universe began? Or how did they appear in the first place? You see, black holes in the early universe couldn't grow as quietly and steadily as many modern black holes do. They were bound to experience some peculiar formation and growth. At the same time, closer to the present day, black holes are believed to be born from the collapse of ginormous stars. They grow by munching on gas, dust, stars, and other black holes non-stop. The friction created in the process makes the material, spiraling into a black hole, heat up, and it emits light that can be detected by our telescopes. To spot the oldest black hole, scientists used two infrared cameras, the JWST's mid-infrared instrument and near-infrared camera. They used the camera's built-in spectrographs to break down the light it had been recording into its component frequencies. While examining the results, they discovered unusual spikes among certain frequencies. It could only mean that the hot material around a massive black hole was beaming out faint traces of light. One of the most popular explanations for how ancient black holes grew so rapidly is that they appeared after sudden collapses of colossal gas clouds. Or they could form as a result of merges between clumps of stars and black holes. There's also a possibility that some of the oldest black holes could have been seeded by hypothetical primordial black holes. Those are believed to have appeared moments after the universe began, but their existence hasn't been proven yet. In any case, this most recent finding of the ancient black hole is extremely important because the formation of galaxies and the appearance of black holes go hand in hand. Every normal-sized galaxy that we know of has a black hole at its center. But even though such black holes are massive and can weigh millions and billions of solar masses, they are still tiny in comparison with their home galaxies. A supermassive black hole usually reaches less than 1% of the mass of a regular-sized galaxy and has a volume that is billions of times smaller. And still, somehow, supermassive black holes can influence galaxies, controlling the formation of stars for billions of years. The thing is, black holes exert an enormous gravitational pull on their surroundings. Any gas, dust, and stars that come too close to a black hole find themselves trapped. A lot of material crams into the space around the black hole and heats up, because that's what materials do when compressed. Soon, everything around the black hole flattens into a thin disk, which is called the accretion disk, and starts swirling around the black hole. Astronomers believe that this process is behind the mysterious relationship between black holes and their host galaxies. It's a connection between the mass of the supermassive black hole and the velocity dispersion of the gas in the galactic core. This cycle also controls the rate of star formation, which is a crucial element of the evolution of galaxies. If this delicately balanced process goes off kilter, the outflows from black holes can get too strong, not only heating the gas in a galaxy, but also removing it altogether. And then, the formation of stars doesn't simply slow down, it stops completely. Major galactic merger events can lead to such dramatic consequences because too much material falls into the central black hole too fast.
Brace yourself. You're about to hear one of the most unusual sounds ever. It's come from space, and it's the sound of two black holes colliding. But first things first. Our ears are designed in a special way, which helps us translate sound waves. But these sound waves become mute once the medium they're traveling through comes to an end. It happens when, for example, the atmosphere of Earth gives way to the vastness and emptiness of the cosmos. At the same time, there are some sound waves that can move even through a vacuum. And we can translate these vacuum-friendly waves into sounds our human ears can hear. That's kind of like radio transmissions work. Over the past few decades, people have sent quite many satellites to the far reaches of the solar system, and even beyond. These spacecraft are equipped with sensors designed to hear such things as radio and plasma waves flowing freely through interplanetary space. These instruments are crucial for research and communication reasons. An additional bonus is that now we can finally hear different kinds of space waves as audible sounds. The results are often ear-splitting sounds, and sometimes audios are downright scary. Usually, when two black holes collide, they don't produce a sound. And still, thanks to modern technologies, we can now listen to this terrifying cosmic event. Do you hear it? This chirping sound is the sound that two black holes produced while slamming into each other around 1 billion light-years away from our planet. Interestingly, the tone of the sound rises when the holes spiral closer to each other and stops abruptly when they eventually merge. Now, do you hear that long, low buildup? It means that the merger is quite slow, more sedate, and the black holes taking part in this event are relatively lightweight. A more abrupt chirp is a sign of a fast merger, where the black holes are rather large. For example, the pair that produced this sound combined and created one black hole more than 80 times the mass of the Sun. Since each of these black holes weighed as much as several stars, they were hefty enough to produce waves while passing through space. I mean gravitational waves. They are undulations in the fabric of space-time, fanning outward at the speed of light. You can probably compare them to the ripples that appear on the surface of a pond after you throw a rock in the water. Naturally, the sound of black holes colliding isn't the only unusual noise recorded by our equipment. NASA's Juno probe passes by Jupiter every few weeks at a speed of up to 130 miles per hour and plows through all kinds of invisible fields in the process. And one of the most powerful signals it has recorded is Jupiter's bow shock. That's the point where the planet's magnetic field pushes against the incoming wind of solar particles. The sound produced during this standoff sounds similar to a sonic boom. Or this sound. It was produced by the Stardust space probe when it was passing through the dust left by Comet Tempel 1. In the process, debris hit the body of the spacecraft. It sounded as if some creature was rapping at the window or hurrying across a hard floor. Let's have a look at NASA's nuclear-powered Cassini spaceship. It spent 13 years exploring gas giant Saturn and its numerous potentially habitable moons. This mysterious and a bit spooky sound is actually radio waves emitted by the massive planet. Such waves are caused by a phenomenon which is similar to the one producing auroras on Earth. Speaking of our own planet, it's surrounded by plasma. It consists of hot, ionized particles generated by sunlight. They're constantly slamming into Earth's atmosphere. NASA's Polar mission, which was launched a few decades ago, managed to record this breath-like hiss. That's what plasma orbiting our planet sounds like. As for these weird sounds, NASA doesn't say which space probe recorded them, but they're coming from Jupiter's largest moon, Ganymede. It could have been the Galileo spacecraft, which orbited the system for around 8 years. But it probably doesn't matter so much. Just listen to this creepy noise that sounds like screams trying to break through from some hidden place.
You might think falling into a black hole is as easy as falling into a giant pit, but boy, is it a whole different ballgame. To actually fall into a black hole, you would need some incredible luck and a dash of wizardry. Moreover, if you were watching something fall into a black hole, you wouldn't even see it. Why? Well, let's try to understand the magic of physics. Falling into a black hole is really tricky. First of all, to even have a chance of doing this, you would need to aim perfectly and start your journey from very far away. It's like trying to hit a tiny target from a long distance. That's because black holes exist within galaxies, which are filled with other objects like stars, planets, and gas clouds. These objects have their own gravitational forces that can influence the path you need to take. It's like you have to carefully navigate through the room, avoiding bumping into others or getting pulled off course by their movements. In a similar way, when falling into a black hole, you need to navigate through the influences of other celestial objects. As you get closer, things get even more complicated. Making even the tiniest change in direction would require a tremendous amount of energy that you wouldn't be able to generate. It's like trying to steer a spaceship with no fuel left. This is because the black hole's gravitational pull is immensely strong. Once you pass the point called the event horizon, there's no coming back. You wouldn't be able to control anything. Now, even if you somehow manage to get on the right path and avoid all the obstacles, there's still a dangerous situation waiting for you. The intense heat and energy around the black hole, called plasma, would fry you as you get closer. So, you would need some impossibly strong protection to get even close to it. But not only is it nearly impossible to fall into a black hole, it's also impossible to see someone falling in it. Why? Let's find out. Imagine you're standing far away from a black hole, watching something getting closer and closer to the event horizon. As this thing, let's say it's a spaceship, falls into the black hole, two very strange things start happening. First, the color of the spaceship will change. You see, the gravity near a black hole is incredibly strong, much stronger than anything we experience here on Earth. This intense gravity affects everything around it, including light. Now, light has this fascinating property where it carries energy. But when light gets close to a black hole, the powerful gravitational pull starts sapping away its energy, kinda like stealing it, making light weaker. And you know how when you look at a beautiful sunset, the sun appears to be this warm, reddish-orange color? Well, that's because when sunlight travels through our atmosphere, it scatters and loses some of its higher energy bluish colors, leaving behind the redder ones. So when light loses energy, it tends to shift towards the red end of the color spectrum. The same thing happens near a black hole. The light from the spaceship loses energy due to the black hole's strong gravity. So, the spaceship, which initially had its own color, starts looking redder and redder as it gets closer to the black hole. It's as if the black hole is casting its magical spell, changing the color of the spaceship itself. The second weird thing is related to time. According to a theory of general relativity, gravity can mess around with time itself. And it works in a very strange way, because none of you, not you, not people on board a spaceship, will feel this change. For you, an observer in this scenario, time is flowing just like it always does. You're just sitting there, sipping your space lemonade and watching the spaceship's journey. For people on a spaceship, things are the same. Their watch ticks away at a regular pace, and they go about their day as usual. But, objectively, for you, it would be like watching a spaceship fall in slow motion. It will seem to you that it's been falling into a black hole for weeks or even years. You might turn 80 and the spaceship is still out there. Crazy, right? Now, if time slows down for the spaceship, it means the light it emits also slows down. So, imagine someone on that spaceship flicking a flashlight on and off. But because time is moving so slowly, the light coming from the flashlight also moves in slow motion. It takes ages for each burst of light to reach your eyes. You'll be watching a spaceship as if you're watching a video in super slow motion. And when light takes longer to reach your eyes, it becomes weaker and dimmer, just like a fading star. So, as the spaceship gets closer and closer to the black hole's event horizon, not only does it start looking redder, but it also appears dimmer. So, it becomes harder and harder to see the spaceship as it gets closer to the black hole. It slowly fades away, like a disappearing act on the grandest stage of the universe. Pretty mind-boggling, isn't it? But that's all about you, the observer. And how are people on board doing? What do you actually experience when you fall into a black hole? As you get closer to the black hole, something really weird starts happening. The gravity near the black hole is so powerful that it stretches and warps everything around it. So the difference in gravitational pull between your head and feet becomes significant. This difference creates a tidal force, which stretches your body like a long, thin shape. It's a process that's scientifically called spaghettification. Essentially, you would be stretched into a human noodle. Being turned into spaghetti might sound fun for a pasta lover, but it's definitely not so great for an astronaut. Meanwhile, colors around you begin to warp and distort, creating a dazzling light show. It's like riding a roller coaster through a rainbow tunnel. Twists and turns, flashes and sparks. It's an exhilarating, mind-bending experience. And then, what happens to you depends on the type of black hole. First, we have classical black holes. These are black holes that exist forever. If you fall into this black hole, it would take an incredibly long time to reach the center. The center would keep getting closer and closer, but you would need an almost infinite amount of time to reach it. So it would feel like your journey would never end. And then we have evaporating black holes. These black holes can evaporate over time due to a process called Hawking radiation. It's just like the ice cubes melting away. These black holes have a limited lifespan, and it's basically impossible to fall into one of them. As you approach the evaporating black hole, you find yourself hovering near its edge, the event horizon. It's like being stuck at the entrance of a super cool amusement park. But guess what? This amusement park is shrinking. The black hole is evaporating, and as it does, the event horizon gets smaller and smaller. So you stay right at the edge, tracking its every move, but you will forever stay in this event horizon without ever crossing it. But remember, once you pass the point of no return, there's no way back. You're on a one-way ticket to the mysterious heart of the black hole, the Singularity. At the Singularity, everything goes bonkers. Our current understanding of physics goes haywire, so it's a bit like entering a magic show. What happens once you reach the Singularity? Is there anything on the other side of a black hole? We have no idea. It's a big mystery for us, but maybe we'll figure this out someday. So, my friend, it's best to admire black holes from a safe distance and let your imagination soar with the incredible wonders they hold. Just remember to keep your pasta on your plate and not near these cosmic spaghetti makers.
Imagine a being so powerful it can suck in entire galaxies, so mysterious it's invisible to the naked eye, and so impressive it bends the very fabric of space and time to its will. Yes, meet my mother. Just kidding. Actually, meet the ultimate superhero of the universe, the black hole star. What is it and how does it work? Well, let's find out. The universe is full of marvels, and the black hole star is one of the most impressive ones. It's a supermassive force that can bend the laws of physics and a true enigma for scientists to unravel. No wonder science fiction writers find them so captivating. A black hole star, also known as a quasi-star, is a hypothetical type of extremely massive and luminous star that may have existed early in the history of the galaxy. They're predicted to be as luminous as a small galaxy, but unlike modern stars, they weren't powered by nuclear fusion in their cores. A quasi-star's energy would come from material falling into a black hole at its core. And yes, just like a normal black hole, these stars have the power to suck in anything and everything that gets too close, including stars, dust, and even entire galaxies. But how is it possible that the star is born from a black hole? And what's more, how do they continue to coexist together? Well, first let's discuss how black holes are born in general. It all starts with a supermassive star, one that is at least a few times more massive than our own sun. This giant of a star burns bright and hot, shining with the light of 1,000,000 suns. But eventually, it runs out of fuel and its fate is sealed. As its lifespan comes to an end, it makes one final massive boom, a blast so powerful it can outshine an entire galaxy. This blast is called supernova. During this boom, the outer layers of the star fly away, while the core gets squished together by its own gravity. If the squished core is heavy enough, it can keep squishing until it becomes a black hole. And just like that, a black hole is born. Don't even try to put diapers on this thing. Now, this cosmic monster baby can continue to grow by swallowing up anything that comes too close, including stars, dust, and even entire galaxies. This is basically what's happening now in our universe with supermassive stars. But what about quasi-stars? The formation of a quasi-star could only happen early in the development of the universe, before hydrogen and helium were contaminated by heavier elements. And because of that, quasi-stars have one important feature. They are gigantic, so enormous that it's literally impossible to imagine. They may have been dwarfing even the largest known modern stars, like VY Canis Majoris and Stephenson 218. No wonder they're so scary. They were born from protostars, one of the first stars in the universe, the great-great-grandfathers of, everything. So now, imagine a protostar so massive that its core collapses into a black hole, just like we described before. But the key difference is that in a regular supernova, the outer layers of the star are blown away by the energy released during the boom. Meanwhile, in a quasi-star, these outer layers are massive enough to absorb the energy without being blown away. What do we get in the end? A star with a black hole in its core that weighs from 1,000 to 10,000 solar masses. This quasi-star is about 14,000 times bigger than our Sun, which makes them bigger than any star we know today. These celestial titans have some pretty crazy properties. Once a black hole is formed at the center of a giant protostar, it starts to give off a ton of energy. This energy helps to balance out the force of gravity, making it kind of a giant fusion-based star. They would be so bright that each one would look like a small galaxy. Quasi-stars would have a pretty short lifespan, around 7 million years. Just for comparison, our Sun is about 4.5 billion years old, and it's only halfway through its lifetime. But either way, during this short period, the black hole at the center would grow to be about 1,000 to 10,000 times the size of our Sun. Quasi-stars are also thought to be super hot, with temperatures reaching over 17,500 degrees. But as a quasi-star gets older, it starts to cool down, and its outer layers become see-through. Eventually, it cools down to a temperature of 6,740 degrees, and at that point, it's curtains for the quasi-star. It can't survive at that temperature, so it just dissipates, leaving behind an intermediate mass black hole. Unfortunately, right now, there's no observational evidence for the existence of quasi-stars. This is because they're thought to have only existed a very, very long time ago. They may have been very massive population 3 stars, which are extremely rare and difficult to detect. It's also very unlikely that any of them would still exist today because of their super short lifespan, only 7 million years. So why do scientists believe that quasi-stars could have existed? Because they're looking for ways to explain how supermassive black holes formed so early in the history of the universe. They're found at the center of most galaxies. But how could these monsters have formed so quickly? After all, it takes a really long time for small black holes to grow into supermassive ones. This is where the idea of quasi-stars come in. These stars aren't just destructive forces of nature. They're like the black belts in the martial art of gravity. They can bend and twist anything to its will. That's why these stars, if they really existed, had to play a crucial role in the evolution of galaxies. They must have been instrumental in shaping the universe as we know it. So, those intermediate-sized black holes that they left behind could eventually turn into supermassive black holes in the center of galaxies. But we're still yet to solve this cosmic mystery. Detection and study of black hole stars is like trying to find a needle in a haystack. Only instead of a needle, it's an invisible and mysterious object. And instead of a haystack, it's the vast expanse of space. But with the help of some pretty cool technology and a lot of brainpower, scientists are getting closer to uncovering the secrets of these celestial giants. Here are some things that can help us in this research. First of all, gravitational waves. They're like ripples in the fabric of space-time. caused by the movement of massive objects. Albert Einstein predicted them way back in the 20th century, but they were finally detected only in 2015. We caught them by observing the collision of two black holes. This discovery confirmed that black holes can merge and that they're a powerful source of gravitational waves. Scientists think that by studying these waves, they can learn more about how black holes form and grow. We can also try to detect quasi-stars by observing the effects of their gravity on nearby objects. It's like trying to spot a criminal by their fingerprints. For example, if a black hole is located near a star, scientists can observe the star's light being distorted as it's pulled toward the black hole. And of course, we can use our technologies, such as X-ray, infrared, and radio telescopes. This allows us to study black holes in various ways and at different stages of their lives. In other words, scientists are working hard to uncover the secrets of these celestial giants. We develop new telescopes, search for primordial black holes, and try to understand the connection between black hole stars and dark matter. And we're making some pretty incredible discoveries, just like with gravitational waves. All these things will bring us closer to uncovering the secrets of quasi-stars. And when we find out the truth about them, it will become a new page in our scientific history.
Black holes are like omnivores. They'll eat anything in their way if it gets close enough, including planets, stars, clouds of gas, or some very unfortunate intergalactic travelers. Not that it really gets hungry and goes after space objects, it simply swallows whatever comes nearby. It stretches giant space bodies until they're thin, like spaghetti, and rips them apart atom by atom. A black hole is a huge amount of matter that comes in a very small package. It's like you squeeze a star 10 times bigger and more massive than the sun into a small area with the diameter of New York City. You get an extremely massive, compact, and dense pit with gravity so strong, not even light can escape, not even another black hole. They don't have a fixed point in space. Stars, planets, asteroids, comets, black holes, and everything in the universe is in constant motion. That's why things get so chaotic from time to time. Researchers found a giant black hole at the heart of one galaxy being eaten by an even bigger one. A black hole can get extremely big. At the centers of most giant galaxies are black holes that can grow millions to billions of times the mass of our sun. One of the ways to become so big is by eating others of its kind. A black hole merging with another black hole is one of the most energetic and powerful things in the universe. Picture this: 1.3 billion years ago, two black holes are circling around each other. The bigger one pulls the smaller black hole inwards, and now they're locked together in a spiral. Through time, that orbit starts decaying, but very, very slowly. These two black holes are constantly getting closer and closer. As they approach one another, the disks of orbiting dust and gases that surround them mix and create an intense towering vortex. It extends and goes pretty high above the center of that disk. At some point, they finally merge into one extra big, supermassive black hole. As they're merging, they kick out gravitational waves. These waves tell us a lot about black holes, but they can't reveal their precise position. So, scientists need some electromagnetic signal that will find the black hole's location, like radio waves, X-rays, or a flash of light. We can't see black holes, but we can detect their effect on space objects that are surrounding them. When a black hole passes through a cloud of matter, its strong gravity will pull matter inward. If a star or a planet comes close enough, the same will happen. The attracted matter then accelerates, which means starts to move very quickly and heats up. The black hole then starts emitting X-rays that radiate in the area surrounding it. The energy of X-rays affects the neighborhood and can, for example, spur the growth of new stars. And finally, bam! They collide. It's a massive burst of energy, one of the biggest bangs ever since the Big Bang. In less than a second, that collision emitted more energy than all of the stars in the visible universe together at the same time. Black holes can become huge, but not necessarily. Stellar mass black holes have a mass similar to the Sun, and they can be very small. The one scientists found in 2019 is located 10,000 light-years away from us and is only 12 miles across. They really have a reputation for destruction, but black holes are just another source of gravitational force, similar to stars. That means it's possible for a space body to orbit them, if it moves fast enough, of course. Let's say there's a black hole with the same mass as the Sun. The speed a space body would have to move at is the same as the one needed to orbit our Sun, if the distance is the same. That's a theory. In reality, planets don't really orbit black holes, because those that have a mass similar to our parent star are mostly the remnants of giant stars that ran out of nuclear fuel and eventually exploded. That's how black holes are created in the first place. And chances are that none of those planets nearby will survive it. But 30 years ago, scientists discovered the first planets beyond our solar system. These planets were found orbiting a pulsar, which is also some sort of supernova remnant. We don't know how they survived the explosion of their parent star. It's possible they may have been created after the destruction from debris that formed after the explosion. Scientists even have a theory that black holes are possibly wormholes, something like tunnels to other galaxies. That means they don't destroy objects they swallow, but send them somewhere. The theory says the object that enters and then goes out on the other side leaves the tunnel through something opposite of the black hole, a white hole. It probably looks similar to its companion, with all that spinning and similar mass. There could be a ring of gas and dust around the event horizon. The event horizon is the point of no return, the part of a black hole where nothing escapes. Unlike a black hole, a white hole lets light and all the matter leave, but none of that will be able to enter the portal once again. About 50 years ago, Stephen Hawking realized that black holes leak energy. Scientists then developed the theory that a white hole could be born out of a black hole. They're still not sure how the black hole disappears, but in this scenario, it would grow so small it no longer can have such strong gravity that makes it swallow other objects. So, it might turn into a white hole then. Such a hole would be similar in mass to something really light, like human hair. It wouldn't be so dramatic as its black hole ancestor, but it would still hide mysteries in its interior, the information of all space objects it had swallowed previously. It would eventually spit out that information and get so big, it would dominate the universe. White hole behavior, opposite of black holes and all that sucking the matter inward, could be compared to the Big Bang explosion, where the universe is expanding and new objects are forming. But even if something like this happens, it may only be possible trillions of years from now. And there's an issue. Even if some big white holes did form somewhere in space, they probably wouldn't last too long. Outgoing objects would collide with the matter in orbit, so the whole system would collapse and turn into a black hole once again, since they're also formed after supernova explosions. Stars, asteroids, comets, galaxies, and planets, all those space things we can see, make up nearly 5% of the universe. About 25% could be dark matter, a mysterious substance we can't actually see, but assume it's there because everything in the universe moves to its gravitational tune. This dark matter is kind of like a spider's web. It holds all those galaxies that move pretty fast together. Its evil twin is called antimatter. Antimatter particles are like the opposite version of the matter, the same mass but opposite electric charge. When they collide, antimatter wipes out the regular matter, and the result is pure energy. Dark matter probably makes the universe expand even faster than it used to do. One of the latest theories says it could be responsible for the huge asteroid strike that made the dinosaurs go extinct, too. The universe doesn't have a center, but galaxies do. The Earth makes a circle around the center of the Milky Way once every 250 million years. This orbit is not straightforward, but we can roughly predict it. Once in every 60 million years, we go through the crowded region of our galaxy, known as the galactic disk. At the same time, we can track some harsh mass extinctions in the history of our planet. including the asteroid that wiped out the dinosaurs about 66 million years ago. Professor Rampino from New York University proposes that dark matter has a gravity that could throw nearby space bodies into the Earth's path whenever we enter the galactic disk. That means some asteroids and comets that would usually be far away from us are flung towards our planet. The biggest thing in the universe, at least the one we know about, is the Hercules Corona Borealis Great Wall. It's a cluster of galaxies 10 billion light-years across, bound together by gravitational force. The biggest elliptical galaxy is IC 1101 and has a diameter of 4 million light-years. The smallest galaxy, Segway 2, we've discovered so far, has a diameter of a little bit over 220 light-years. It's pretty faint and has only 1,000 stars. For comparison, our galaxy has 100,000 million stars. It orbits the Milky Way.